What is a system? A system is defined as a group of objects that are joined together in some regular interaction or interdependence toward the accomplishment of some purpose. So what brings the definition of system together is these two words. We have objects which are interacting with each other, and they show some interdependence, and there's a purpose which is a common purpose of the whole system. The objects may have some independent purposes as well, but if we are going to define a system, the system must have a purpose for the reason of existence. So we have several objects. Imagine a manufacturing system, automobile manufacturing system. And in this system, the machines, the component parts, the sub-assemblies, workers, equipments, these are all the objects of the system. And what is the purpose of the system? Production of high quality vehicles. So we can give several examples to a system. I mean, you can imagine the solar system as a system, or you can imagine a human body cell as a system. Okay, so there are several objects in it, and there's a certain purpose, either for existing or for aiming towards another objective. We can give a general definition to system like this. Now, a system is often affected by the changes occurring outside the system. Okay, every system actually exists in an environment, and that environment is called the system environment. Okay, so actually there are changes or dynamics within the system itself as well. So the system affects itself as well. However, there are also effects coming from, or influences coming outside the system boundaries. This is called the system environment, and the system boundary is the separation of the system from its environment. For example, imagine a bank system. Okay, the client's arrival process to a bank is outside the influence of a bank. So a bank cannot exactly determine when the clients are going to arrive to get service. I mean, you can, of course, have a control over these kind of things with an appointment system, of course. But I mean, in banks, we usually do not observe such a situation. So the arrival process, the arrival of the clients into a bank is defined by the system environment. It is a part of the system environment, and we basically do not have a control over it. However, the service policy, okay, the queuing policy in the system, in the bank, is controlled by the bank, and it is a part of the system. So the policy determination, the policy itself, is also another component of the system. However, as I have said, the arrival process is not a part of the system. It's not a component of the system, so it exists in the system environment. So what are the components of a system? We are going to model systems with some components, and these components can be classified according to the following list, and it is very important for us to understand these components. Actually, we are going to use these components when we start modeling systems with Arena software as well. So these components are the common terms used by many simulation software and by simulation experts. Okay, it is very important for you to understand these concepts, and I'm just going to give examples in different systems as well. Okay, so we are going to start with the first component, the component called entity. What is an entity? Entity is basically an object of interest in the system. So imagine a bank system, and the clients here, the customers basically, but the client is more formal term for banks. Clients are the objects of interest, so they come and go to get service, and their satisfaction is very important for the bank. Okay, so clients are the entities in the system. We say an object of interest in the system, which usually enters from outside the system and then again leaves the system after spending a certain amount of time within the system. Okay, so these are the typical properties of entities, but that's not always the case, of course. An attribute, what is an attribute? Attributes are the properties of entities. So imagine the balance in a client savings account. So in a bank, too many clients are coming and leaving, And what is the difference between these clients? These clients have different balances in their account, right? So the balance in the accounts of these clients are defining them. But sometimes they may have the same balance as well, by chance. It is possible. I mean, two different clients may have the same amount of money in their account. However, that attribute is putting the differences between the clients, right? So that attribute or property is defining the entity. And credit rating. So many clients may have different credit ratings, but every client has a single credit rating at that time. And that credit rating may change over time. I mean, after a while, where the client stays a client for the bank, the credit rating may increase or decrease as well. And identity number or citizen number is another attribute. And this attribute is a unique key, basically. I mean, multiple entities may not have the same identity numbers. So attributes are basically the properties of entities. Entities are what is written in their forehead. Okay, so for every entity, to define them, we are tagging them with some label, and these labels are attributes. So what is an activity? An activity is a time period of specified length. Okay, so it's a time period. Do not forget about this. Activity is not an event that momentarily occurs. Okay, activity is a period of a specified length. So it should take some time, some duration. It should have a duration. So making deposits in a bank or withdrawing cash or investing in bonds, these are all activities. So they all take some duration, some amount of time to perform. Now, we are going to continue with state variables. What is a state variable? It's the collection of variables necessary to describe the system at any time. It says, now imagine this. You are in a bank, you are observing it, and in this bank, the clients are coming and going, and they are taking services. And there are many servers, there are many resources to give service to these clients, okay? Now, at some point, just pause the system, okay? Freeze everything. Take a snapshot of this system. Now, whatever you observe in that system at that moment can define a system variable. For example, the number of busy tellers at that moment, okay, at that time. I mean, you can count which ones are busy at that pause time, at that snapshot, and which ones are idle, okay? The number of busy tellers at time t is a state variable, okay? And the number of clients in the bank at that moment. So how many clients do we have at that exact moment is another state variable. So the name itself gives it away, state. So it depends on some state of the system at time t, okay, at a certain time. So how do we distinguish a state variable from an attribute? The attributes belong to clients, but state variables belong to the system. Okay, it defines the system at any time point. Okay, again, when you fast forward of the system and then pause the system once again, state variables are going to take different values. Maybe afternoon, the number of busy tellers are going to increase and the number of clients will increase as well. Okay, and finally, events. What is an event? Event is an instantaneous occurrence. Okay, it is an instantaneous occurrence. It just takes a moment, and that might change the state of the system. Okay, events usually change the states of the system. Okay, for example, arrival of a new client from outside the bank is an event which is changing the state variable, which is the number of clients in the bank. Because if an arrival occurs, the number of clients in the bank increases by 1. Okay? And service completion is what? Again, an event that changes the state variable, again, the number of clients in the bank. So with service completion, the client is going to leave the system, and this is an event that changes the number of clients in the bank. Okay, so events are instantaneous occurrences which do not take any time. It's not just an activity, it's an event. Okay, the difference between an activity and event is this: activity takes some duration, and events usually change the state variables. Okay, now the difference between the arrival of a client and the service completion of client is what? The arrival of a client is an exogenous event that occurs outside the system. So arrival occurs in the system environment, so it's an exogenous event for the system. But the service completion of a client is an endogenous event that occurs within the system itself. Now, if we intend to give another example to a system, we can give the rapid rail system in a transportation network, and the entities here can be the riders, okay? Actually, the lines, the rail lines. And attributes are what? The origin and the destination of these riders. Okay, so where they are going to take off from and when they are going to go to. Okay, origin and destination can be the attributes. Every line has a different origin and has a different destination. For example, if you have Van Gölü Express usually has an origin from Istanbul to Van or vice versa. So it depends on the time of the ride actually. And let me give you another attribute, for example, the number of seats in that rider. Okay, how many seats do we have in that rider is also another attribute. So what are the activities here? Activities are traveling. Okay, the riders are traveling from one location to another, and this activity takes some time to do. What are the state variables? Now, if you take the snapshot of this rapid rail system, at that time t, some of the riders are going to be parked at a station, and some of the riders are going to be moving in the transit at that snapshot. Okay, so these are going to be the moving riders are going to be the busy riders, the others are currently idle riders. So the number of riders at each station and the number of riders in transit, riders at a certain district is going to be a state variable. Okay, and that may change through time. And events are what? Events are the arrival of these riders to stations and or the destination or departures. Departures are events. So they do not take any time. They are assumed to occur momentarily. Okay, imagine a warehouse system now, a global inventory system where this global warehouse company has too many warehouses in different countries, in different geographic locations. Okay, what are the entities here? The warehouses are the entities. Now you see, not in all systems the entities are moving. Not in all systems the entities are coming from outside and leaving the system after a certain amount of time. Okay, so entities in this global inventory system are positioned at static locations. Okay, and the attributes of entities are what? Capacities. Okay, you can open a new warehouse, of course, or you can close a old warehouse, and the capacities of these warehouses are going to be attributes. You can also change the attribute. I mean, you can increase the capacity of a warehouse or decrease it as well. What are the activities here? Withdrawing materials from the warehouses are activities which take some time. And what are the state variables? If you take the snapshot of this system, you can basically count the number of items that are stored in each warehouse at that instantaneous moment. Okay, so level of inventory in each warehouse or the backlog demand. The backlog demand, I mean, maybe you do not know the definition of this term, but if you do not know it, please take a look from Google. And rejected demand, the rejected amount of demand by each warehouse up to that point is a state variable. Okay, so not just the things that we count at time t, the total amount of events that have occurred until time t can also be a state variable. For example, imagine bank, we say in the bank at time t, how many clients do we have inside the system? It's a state variable, but another state variable can be the total time of clients that have been served until time t. It is also a state variable because though you cannot see or observe that variable on the system when you freeze the system, still it is recorded somewhere in the system. Okay, the total number of clients that has been served has been recorded in the system at some point, and that value belongs to that moment. Okay. Now, of course, if I want to give a complete list of components like this, entities, attributes for any system, actually what I need to know is the problem that I am trying to solve and the purpose of the simulation study. I mean, the entities, attributes, activities, state variables, and events, it depends on the problem that I am considering, the problem I'm trying to solve. And therefore, I cannot give a complete list of these components. I'm just giving practical examples here. But as I have said, entities, attributes, activities, these are all dependent on the problem that we are studying. Now, there's a classification of systems. The systems can either be discrete or continuous. Now, it is usually very hard to understand this difference between these two classes. So you need to be very careful at this point. A system is discrete, we say, if the state variables are changing at discrete set of time points. Okay? The sentence is not saying that a system is discrete if the system variables are discrete. It's not saying that. Please be careful. A system is discrete if the state variables are changing at discrete set of time points. Okay? So an event occurs at a time point, and another event occurs at a separated time point than that. Okay? So there is not a continuum of events. The events are not occurring continuously in discrete systems. The events are occurring at discrete or separated time points. Okay? For example, banks. In a bank, no two clients can enter the system at the same time. There is at least a certain time difference between two entrances, okay? Maybe it is a very small time difference, but that time difference exists. Or multi-story car parks. Again, the events are occurring, or the state variables are changing at discrete set of time points. Now, what is a continuous system then? A system is continuous. Variables are changing at continuous set of time points. Okay, so over the time, the state variables are changing continuously. Okay, for example, the water dam. Okay, so when it rains, okay, when it rains or when people withdraw water from the water dams, it is a continuous process, right? So you cannot extract, for example, 2 tons of water immediately. It takes some time, and the level of the water is going to reduce in a time. And that state of variable, if we consider the amount of water behind the dam as a state variable, that state variable is going to change continuously over time. Okay? Or stock market, in the stock market, the stock prices are changing continuously over time. Okay? It is affected from too many things, and the amount of water behind the dam is also affected by too many things. It is affected by rain. It is affected by every single individual's withdrawal. And the stock market is affected, the stock prices in stock market are affected by the transactions, and the transactions are occurring almost continuously over the time. So we say that these variables, state variables, are changing at continuous set of time points. Therefore, such systems are continuous. If at least there exists a single state variable which is changing continuously over the time, then we say that this system is continuous. Okay, if there exists at least one variable that changes continuously over the time, then that system is a continuous system. Okay. Now, the common misperception about the discrete systems is the system variables themselves are discrete. No, it's not actually the case. The system variables can also take real values or rational values as well, so they can be continuous as well. I mean, imagine an inventory system again, but this time, unlike to a water dam, the product is a measurable product, like the amount of gasoline in a gas station. And it changes discretely. We assume that it changes discretely. So when a tank brings new gasoline to the gas station. It is immediately transferred to the warehouse, okay, the depot. So we say that it is changing discretely. But the amount is a continuous amount. So please do not confuse these things. So we say that a system is discrete if the state variables are changing at discrete set of time points. Otherwise, if the state variables are changing at continuous set of time points, then we say that system is continuous.